Okay, so while 3.1 was talking about measures of central tendency, talking about data in the middle, 3.2 is measures of dispersion. It talks about how the data is spread out. Because you can have the same average between two numbers. For example, the average between 0 and 100 is 50. But the two numbers are very far from 50. The average between 49 and 51 is also 50, but those numbers are less dispersed. So that's one of the things. So the first thing we can talk about is the range. The range is simply the largest value minus the smallest value. So the following data represents the travel times to work for 7 employees, the same one as in 3.1. Find the range. Simply take the largest minus the smallest. And that means there's a 38-minute range between the person who gets to work the fastest and slowest. Now, a much more complicated, not really complicated as an idea, but complicated to mathematically calculate, and we'll learn doing this in your calculator is easier, is standard deviation. Standard deviation is used along with mean to describe distributions that are bell-shaped and symmetric. So the mean measures the center, standard deviation measures the spread. This also means the sum of all deviations around the mean must be equal to 0. So basically, standard deviation is how far from the center on average something is, roughly. So if there's something above the mean, there has to be enough stuff below the mean to offset the exact value. So if the mean between 3 numbers is 10, and you know one of the numbers is 10 and one is 12, well, you know, in order to offset that 12, which is 2 above the mean, you need something 2 below the mean, so the lower number needs to be 8. The larger the standard deviation, the more dispersion there is in the data, meaning the data values are more spread out. It's the 0 and 100 argument versus 49 and 51 again. Now, this formula can look intimidating, but it's really not that bad. We'll calculate it by hand. So the following data represents the travel times in minutes to work for all 7 employees of a startup web development company. Compute the population standard deviation of this data. Okay, so in order to do this first, I need the mean, which means I have to add them all up and divide by, looks like 7. So we've got 59 plus 41, that's 100. 131, 174. So I'm gonna, for the sake of our lives here, I'm gonna change this to 6. And you'll see why again. So when I add them all together, and divide by 7, I think I get exactly 25, which is helpful for us. So we take all of these numbers in the list. It doesn't matter the order you put them in, but I usually go lowest to highest. 6, 18, 23, 23, 26, 36, 43. And we need to subtract off the 25. The average is 25 for all of them. So you can go ahead and fill in the column with the 25. And so why are we doing that? If you look at this formula, it says sigma, which is the standard deviation, is the square root of the sum of all those differences that we're about to subtract squared divided by the total number in the population. So we're going to do this part where we take the differences and square them and then add them all together first, which is what this table is for. 6 minus 25, negative 19. Here we've got negative 7, negative 2, negative 2, 1, 11, 18. Now I need to take all of the numbers here and square them. Remember, when you square something, it always becomes positive. So 361, 49, 4, 4, 1, 121, 324. And again, you have a calculator for this. Now, this thing, it's kind of, I feel weird about saying sigma and sigma. This is lowercase sigma and capital sigma, which is the same Greek letter. But this, the big capital sigma, means sum. So we added these all together. So these two are 410, This is 418, 419, 540, 864. We'll check it just to make sure. Yeah, so what do I do with this 864? That's this whole numerator in the fraction. So whatever that is, it goes up here. Now it says you have to divide by big N, which is the number of terms, which we know is 7. And then we'll take the square root. So what is 864 divided by 7? It is 123 point, we'll go for 3. And then I need to take the square root of that. You can take the square root and just leave it as 864 over 7 if you want to be the most accurate without rounding. But that means this thing is approximately 11.11. Now, you can imagine this only had 7 numbers, and it wasn't the most fun. However, if you simply put the numbers in your calculator and follow the steps below, if you have the scientific calculator, it will calculate it for you. So what I will tell you is, because I can't be there to troubleshoot your calculators for you, is you really, really need to Google how to use your calculator to find things I tell you to put in the calculator. Usually on the test, I leave the number of things you find in the standard deviation of a relatively small number. What that will allow you to do is that if you have to do it by hand like this, you do have enough time to do so. Now moving on. In addition to population standard deviation, there is also sample standard deviation. And what's the difference? It is the exact same formula, but sample standard deviation is considered lowercase s. Instead of subtracting mu, we're subtracting x bar, but x bar is still just the average, but it's of our sample. Now you'll notice one specific thing is we divide by n minus 1 instead of n. And that has to do with what we call degrees of freedom. The best analogy I can use about this is the donut analogy. If there's a box of 6 donuts and 6 people are going to pick one, the first 5 people have a choice between some donuts. The first one has a choice between 6, then 5, then 4, then 3, then 2. The last person doesn't actually have a choice. So because we know the mean is a certain value, and we know the standard deviations have to weigh each other, like outweigh each other on one side or the other of the mean, the moment you get to the last number, you know exactly what it has to be. It no longer gets to choose. So we can't say that that was spread because the mean was affected by it, that last piece of data before. So it can't really be included in the spread. Again, if you have 4 points and you know the average is 5, and you have a point that's 1, 2, and 8, you know the last one has to be 9 so that the average is 5. There's no freedom there. That last one is 4. So it's the same as the 8, 10, 12 we did at the beginning. Now, why does this matter? We'll pick it up and do a sample standard deviation in the next video.